Hello everyone and welcome to today's stream where today we're going to be talking about the application of derivatives with some problems as well. So go and just get started. But first let me actually just start by eliminating some of my windows here. Um, Save that first. Yep. Okay. There are a lot of dropped frames, unfortunately. Uh, there's no data. Wait, what? Oh wait, no, never mind. There is some data. So yeah. Okay. So yeah, let's just actually go and just jump into the problem straight away. So the first one here is, let's actually just go ahead and just type this guy first. The gradient of the curve y equals to 8x minus 3x squared at a point B is the same as the gradient of the curve y equals to x squared minus 6x plus 1 at 4.7. Find the value of A and of B. Okay, so first things first, let's just go do that. There we go. So this is the very first problem here. So let's actually just check here just in case. Okay, the connection is very good. Good. So yeah, the first thing that we actually do is that we will just start by actually just writing down everything that we have. Let me actually just transform that to a square. There we go. This one as well. There we go. So yes, the first thing that we are going to be doing is to try to figure everything out. So first, we know that the gradient of the curve y equals 8x minus 3x squared at a point B. This means that a point B is actually on the y equals 8x minus 3x squared. So therefore, when you just plug the numbers in, so when you just put x equals to a, the result must equal to b. So let's actually go ahead and just write this guy down first. Well, let me actually just set up the properties. There we go. So yeah, first fact. Oh, wait, no, first. Let's just actually write everything that is known to us all. You know what? Let me just actually just type this guy in. So the first one is, what do you know? First one is that a point B is at the curve 8x minus 3x squared. Let's call this function x. So yeah, y equals to function of x there. Second thing that we know is that we know that 4, 7 should be at a point, but yeah, you can just go ahead and just plug the numbers in, and you should get the correct answer, which is 16. Wait, what? Gradient of the curve. Wait. Something is not adding up. 16 minus 24. Um, okay. Uh, okay. There might be a there might be something wrong with the question. I'm just starting to check. This was chapter 15. Let's see at the back of the page. 15 dot miscellaneous exercise. Okay. So yeah, basically this guy here should be 4, -7. I believe it is the mistake on the printing, so yeah, it should be 4.-7. And so yeah, we know for a fact that 4.-7 should be inside this curve, because when you just plug the numbers in, it's 4 squared, that's 16, minus 24, that's -8, plus 1, that's -7. So yeah, we know that 4.-7 is at the curve. So yeah, we can just write this guy in. 4.-7 is at the curve y equals to g of x. We will just call this a different function. So yeah, let me just copy paste this instead, just to make this a bit more neater. There we go. And then another fact that we have is that the gradient at point A must equal to the gradient of the other function at point 4. So how would you actually try to write this guy down? You could just say that f accent of, when you say A, here it is at point A. So yeah, basically the gradient at point A of the first function must equal to the gradient of the second function, which is 4 here. And so we can just start solving this entire problem. First things first, what we can do is that let's just go ahead and just start by doing some writing. So yeah, first we know that y equals to 8x minus 3x squared. So when you just substitute a point b into it, you'll get b equals to 8a minus 3a squared. There we go. And then after that, we know for a fact that yes, function prime of a must equal to g of prime of 4. So let's go ahead and just first try to find this first prime. F prime of x. So first, let's just try to find the derivative of 8x, which is 8. And then after that, it's negative 3x squared. When you just derive that, the 2 will go to the front. It's 2 times 3, that will be 6. So it's negative 6. Multiply that by x to the power of 2 minus 1. That's 1. So you don't need to write anything there. So that's the first derivative. And so when you just plug in f derivative of a, this must to equal to 8 minus 6a. There you go. Secondly, let's go and try to find g prime of x. First, let's just derive this x squared here, which would be 2 goes to the front, x to the power of 2 minus 1. We don't need to write anything. Minus 6, because this guy here is an only x. So yeah, if it is an only x, you would just only care about the coefficient. And then plus 1, if it is a constant, you don't need to write it again. So yeah, it's 2x minus 6. And so when you just plug in g prime of 4, what you'll get is actually this guy would equal to 8 minus 6, which would equal to 2. And so we can actually use this third point here to find out what a is. So we know that 8 minus 6a equals to 2. So when you just try to solve this guy, this would be 6 equals to 6a, which means that a would equal to 1. And that's our first thing. We have found the value of a, but we want to find the value of b. So let's just go ahead and just plug this guy into the very first equation. This would give me that b would equals to 8 minus 3, which would equal to 5. As that is the answer of this problem. So a is 1 and b is 5. And so yeah, that's basically the way for you to find this a and b problem of this first question. So yeah, that's that. So yes, we are gonna be going to the second problem pretty soon. So yeah, but yeah, before that I need to just to clean up some stuff first. Okay, yeah, okay, there we go. It's fine. Okay, so yeah, that's the very first problem. I just thought that my mic actually didn't work. Did my mic actually work? Let me actually just check this guy first here, just in case. Um, let's actually listen to this a bit. Okay, yeah, the mic is still on, so yeah, it's pretty good. Everything is fine. You don't need to trouble off anything. So yeah, that's the first problem that we have. Second problem here is number 7 of the book. Okay. Sorry about that. But yeah, I am actually a bit sick, so yeah. But yeah, I guess that's fine. Second problem here. Number 2 here, which is the 7th of the book. Given that y equals to, I don't know how to write this guy a more great way, but yeah, I guess I'll just write it like this because I don't have the tools that I have. Something like that. Yep, squared x minus 2. Prove that dy over dx equals to square root of x minus 4. Divide the entire thing by 2. Let me just cage this guy in. 2 times square root of x minus 2 squared. There we go. I hope that's pretty clear. I hope so anyways. Oh wait, the question is not yet finished. Okay. Hence, obtain the obtain the equation of the normal to the curve y equals to y equals to, okay, let's just copy paste this guy in. At the point on the curve where x equals to 1. Okay, so first things first, that we want to try to find. Okay, so yeah, the first question is to prove when you just derive that y equals to something there, the result is squared x minus 4 over 2 squared x minus 2 squared. So yeah, the first thing that we will actually do is to just to prove this thing first. So yeah, the first thing that you need to notice is that, yeah, this guy here actually has two parts, the top part and the bottom part. When you see this, you want to use the quotient rule, because because the quotient rule is actually it is much more suited to solve this problem instead of the product rule. Because when you just try to use the product rule here, you must make it into a power of -1, and then after that you need to do some crazy chain rules. So yeah, we don't want any of those. Instead, we want to just to solve this by using the quotient rule. So how does the quotient rule actually sounds? If you don't remember, it's actually u over v. So when you take the derivative of u over v, this would equal to u prime of v plus, no, minus, sorry, minus v prime of u, divide them all by v squared. Or like, yeah, it would be like uv prime, but yeah, but yeah, it depends on how you actually like to write it. So yeah, first things first, let's just actually go ahead and just separate these two things here. U here would be x, because yeah, because this part here is at the top, and then the squared x minus 2 is at the bottom, which means that v here must equal to squared x minus 2, something like that. So from here, we want to try to find what u prime here. u prime is u prime is a very simple thing. What is the derivative of x? It would be 1. It's so simple. And then let's try to figure out what's the derivative of v prime here. V prime here is, it is a bit tricky, but yeah, you could just solve it. This guy here is x to the power of half, and that means that the half would go to the front, to the power of x to the power of -1 over 2. Which you know that x to the power of -half is actually 1 over 2 squared x, as that's the answer. And so we just need to plug in the entire numbers just to get the this proven disk. So when you just plug the entire numbers in, 1 u prime here, it's 1, multiply that by v, which is squared x minus 2, subtract this by v prime here is this 1 over 2 squared of x, and then after that you want to multiply this by u, which in this case is x, divide them all by the square root of x minus 2, this entire thing squared, And so we have gotten this back part here. We just need to solve the others. So we can just actually just simplify this. This guy here is the power of 1. The bottom one here is the power of half because it's x to the power of half. That means that we can actually just cross each other out to get ourselves the square root of x. And so when you just have square root of x subtracted by the negative of square root of x, you'll get a square root of x over 2 minus 2 divided by square root x minus 2 squared. This would equal to, let's actually just, let's make sure that this bottom side here would be the same here. The top of the bottom, no, the bottom of the top, yeah. So you'll have square root x minus 4 divided by 2 divided by this big guy here, square root x minus 2 squared. And so when you simplify this again, it's square root of x minus 4 divide the entire thing by 2 times the square root of x minus 2 squared, as that's the answer that we have already proven. So we have proven that dy over dx here is actually square root of x minus 4 over 2 to the square root of x minus 2 squared. Good. And now we want to try to find the normal to the curve. So let's just actually go ahead and just try to figure this out. What is known here is that, no, what is known is that the normal curve, obtain the equation of the normal to the curve. So yeah, you want to try to find the function, the equation. So first thing that you do is that y minus y1 equals to, or let's put that as a subscript there. There we go. Y1 would be m of n. Could you just do that same thing? Nope. I think I can though. Let me just drop it down for you. Subscript. There we go. We don't need that. Okay. And now the entire thing is broken. Square root of x minus x1, and that's the formula of the line. So this is basically the line equation. It should be pretty familiar to you all. And then after that, you want to figure out what is the normal of what is the normal of this curve. So yeah, first things first is that you know that the gradient of the tangential one, multiply that nope let's make that too big one again, multiply that by m of the subscript n subscript n, and then we will enlarge this again, equals to 1. We know about this fact because, like, yeah, because of the tangent and the normal is actually, oh wait, no, sorry, it's negative 1. It is perpendicular to each other. That's why we have this thing. That's why we have this function here. We know that a gradient with another gradient will be tangent. No, will be perpendicular if the result of their product is negative 1. That's why. So yeah, well, let's just go ahead and just figure this out. First things first is that we want to find out at what point does it at at what point is the function is at. this is this is something that you use to just to plug in this x1 and the y1. So let's go and figure out this x1 and y1 here. We know that the point where x equals to 1. We want to find the normal of the function to the curve where the x is 1. So yeah, the x would be 1, and then what's the y? We want to plug this 1 here inside this function here. The very first function that you'll have, it will be 1. So the result will be 1 over 1 minus 2, that will be a negative 1. So that's the point. And then after that, you want to figure out what is the gradient. Well, luckily you have already figured out the derivative of the crazy function, and so you can just try to figure out when this y prime here um evaluated when x equals to 1. This is something that I normally write it just to show you that, yeah, I know that I know that y is a function of x, but yeah, maybe like you don't really like to say like y open bracket x close bracket. So yeah, I would just write this as y prime evaluated. That's that big line of x equals to 1. So when you just evaluate this, you want to plug this number inside here. What you'll get is that it's 1 minus 4, that's negative 3 over 2. So it's negative 3 over 2. Negative 3 over 2. And what's this? The the derivative is the gradient. You know that. But what type of gradient? This is actually the tangential one. So yeah, this is the one that is the tangential one. So when you just try to figure out what mn is, this would equal to, obviously you can just flip the signs up just to get yourself a 2 over 3, as that's the gradient of our function. But we want to know what is the equation of the normal line. We want to know about that. So, so you just need to plug it into the formula that you have. Y minus negative 1, that's plus 1, equals to the gradient here, which is 2 over 3 of x minus 1. So simplifying this, you'll get y equals to 2 over 3 x minus 2 over 3 minus 3 over 3, that's minus 5 over 3. And this is the answer for the question. See? Derivatives is actually a pretty simple thing to do. So yeah, that's how you actually solve it. So yeah, we have here Jeffan and also Sanal Badak. Hello. So yeah, if you have any questions, you can just go ahead and just ask it straight away. Let's go to problem 13. Okay, let's start this one. Okay, find the equation of the tangent to the curve y equals to x to the third power minus 8x squared. Oh, whoops. Okay. Oh, what just happened? Drop it back down. There we go. Subtracted by x squared. There we go. Plus 15x uh, 15x at the point 4 point negative 4. Calculate the coordinates of the point where the tangent meets the curve again. Okay. This is a bit of a trickier question, but yes, this is actually solvable. So first things first, let's just go ahead and just check. 64 plus 60, that's 124. Subtracted by 60. Wait, what? Something is not adding up again. X cubed minus 8. Oh, yeah, yeah. I forgot the 8 there. So that's 64 minus 16 times 8. That would be 96. No, nope. No. It's 16 times 8. That's 128. Yeah, 128. Yeah, the result is negative 4. So it is correct that yes, the point 4 point negative 4 is at the curve. Good. This is a very good thing to have. So we want to find the coordinates where the tangent meets the curve again. We cannot solve this unless we have this tangent line. So first that we want to find the tangent line. But yeah, the node is something that we don't really have a lot of. But yes, what we can actually do is that we can actually just start by finding out what is the equation of the tangent line. So to find the equation, you'll use the same thing. Y minus y1 equals to m of x minus x1 there. And so when you just try to figure this out, you know that the x1 here is 4, the y1 here is negative 4, but what is the m? The m here is actually the gradient, right? And you know how to find the gradient of a curve at a certain point just by taking the derivatives. So yeah, you can go ahead and just try to figure out what y prime here is. It's x cubed, derived, that will be 3x squared, minus 8x squared, that will be minus 16x, plus 15. There you go. And then after that, well, yeah, when you have this guy here, you want to find what is the gradient of the curve when x equals to 4. That means that we want to evaluate this guy. We want to evaluate y prime here when x equals to 4. So let's just go ahead and just plug the numbers in. 16 times 3, that's 48, minus 64, that's negative 16, plus 15, that's negative 1. So the y prime here is negative 1, which is exactly what I calculated it to be. Good. So plugging the entire numbers in, you get this negative 4 here, which makes this a plus 4. Y plus 4 equals to negative of x minus 4. So you'll figure out that y equals to negative x. Very good. But this is not the question that we want to solve. We want to find the coordinate of the point where it crosses again. How would we actually solve this problem? the key here is that we know that when y equals to negative x would meet again at y equals to x cubed minus 8x squared plus 15x is at a certain point. It is where the x is the same and the y is the same. And because that we know that the y is that the y would be the same, you could just actually just write this function minus no sorry this equation x cubed by this equality, I guess, plus 15x. So you can just put this negative x to the right here. You'll get x cubed minus 8x squared plus 16x would equal to 0. And now we need to factorize this entire thing. First things that I can actually see is that the x can actually be taken out. So x squared minus 8x plus 16 would result to a 0. And then after that, I want you to notice this. This 16 here is actually a square, right? It is a square number with the length of 4, obviously, so it's 4 squared. But then you also realize that the 8 here is actually when you just divide it by 2 actually also results to 4, which is basically one of the core well one of the core laws, I should say, is that it is it is it is not a law, it is like an identity. So yeah, a minus b squared would equal to a squared minus 2ab plus b squared. We know about this. We know about this fact. So you can just actually just do this, and you'll actually solve that x minus 4 squared would equal to 0. So that means that there is actually 2 points where it crosses, when x equals to 0 and when x equals to 4. And we have already solved the one that crosses 4, but we haven't actually calculated the one that actually evaluates to 0. And yeah, we know about this fact that yeah, the point will be at 0, 0.0, because when you just put the 0 into this guy here, it would also result to a negative 0, which is basically 0. And that's the answer, which I haven't actually write. So let's write that down first. There we go. We have I have just completed that part. And so yeah, that's basically that. So let's go to the next question. Number 15. Number 15. So let's actually just add a new artboard. How do you actually add a new artboard? Step no. Why did I forgot? How do you actually add a new artboard? Oh, edit artboards there. Ah, yeah, it's that one there. And so you'll add a new one there, and let's actually just get started with this one. Problem 15. Sorry about that. So, find an expression for the gradient of the curve y equals to x cubed. You know what? Let's actually do that later. X cubed plus px squared plus 2x plus q there you go. where P and Q are constants, given that the tangents at A 0.Q and B 2.5 are parallel. Find the value of P and of Q. Okay. Okay, so first things first that we want to notice is that we know that point A and point B is actually at that curve. We know about this fact. And so when you just plug in the Q there, it would be Q equals to Q, which would be useless. But when you plug in 2, it actually gives us a equality. 5 would equal to 8 2 cubed plus 4p plus 4 plus q. This would simplify to 4 plus q, 4p plus q, which would equal to negative 7. Good. And so that's the first equality, but we need another equality. And we know that the slope at point A and point B must be the same because they are parallel, which means that when you actually just take the derivative and plug in 0 and 2, the result must be the same. So let's go ahead and just figure out what y prime here. Y prime here is actually simply 3x squared plus 2pxy, because p here is a constant. So yeah, you don't need to care about if p is a function as well. No, you don't need to care about that, because the p here is a constant, plus 2 because of the x. So when you actually just plug in the numbers here, when you evaluate it at 0, x is 0, 0 plus x is 0, 0, so it's 0 plus 0, that's 0, plus 2, that means 2 would equal to this other guy here, which is 2 squared, that's 4, times 3, that's 12, and then 12 plus 2, that's 14, plus 2p times 2, that's 4p, and then so you can solve this guy as 4p equals to negative 12, which means that p is negative 3. And so you can just solve what q is. So put this number inside here, negative 12, q is 5. Negative 3 and 5. And that's the solution. So that's pretty quick. So yeah, let's actually go to the next problem. Let's just check my OBS just in case. Yep, my OBS is doing fine. Very good. Let's go to the Illustrator again. Oh yeah, this is actually number 4. So, number 5 here, which is the part 17 here in the book. The line y equals to 2x minus 16 is a tangent to the curve y equals to ax cubed plus bx. Okay. at the point where x equals to 2. Find the value of a and b and of b. Um, okay, so you got this function which is tangent to the curve at the point where x equals to 2. First things that you want to know first. A tangent line would actually cross the function. It is a true fact. So when x equals to 2, the tangent line will cross the curve, but it crosses only at one point. So it basically just touches it. But you can actually just solve it using this principle. You know that the y of one value must equal to the y of the second value when the x equals to 2. So when you just plug the numbers in, 4 minus 16, that's negative 12. And then this guy here, it's 8a plus 2b. And these two must equal to each other. So we know that 4a plus b equals to negative 6. That's the first equality that we got. But then, what about the second equality? You need to think a bit more. The tangent line. So, you know, you know what is the gradient, because you know about the line. The line here always states that this 2 here is actually the gradient. Everything before, so yeah, basically anything that is multiplied by the x for a linear equation, that's the gradient. So in this case, the gradient must be 2 when it's at x equals to 2. So when you just try to evaluate where is this gradient, you would just go ahead and just first try to find the derivative of the function plus b. The gradient here must equal to 2. We know about this fact. Or you can actually just derive this guy to figure out that the gradient here is 2 all along. 12a plus b. So now we got these two equalities. So we just need to solve for one of them. The first thing that I see is that this 12a plus b could be actually be subtracted by this other guy here. 4a plus b minus 6 there. Do the entire subtraction. This would actually cross each other out. 12 minus 4, that's 8. A equals to 8. That means the a would equal to 1. Good. So now we just need to find what b is. The key is that just put the number in, because like when you have found a, you just choose one of the function that you like the most, and the answer would be negative 10. So yeah, when you just put it on the first one, that would be 4 plus b equals to negative 6, which you'll know that will be negative 10. Or you could actually just plug it into this one here, which would make it that 2 equals to 12 plus b, which means that the b is negative 10 as well. So that's the answer. These two guys here are the answers. So that's a simple one, I should say. And now let's actually go to problem 19. So yeah. But yeah, before that I need to just clean my stuff again, because I know that I am actually a bit sick. I got like I don't know what's the name. I know, but yeah, I got like some coughs and some sneezes, I should say. I didn't catch a cold, but yeah, I guess that's something. So yeah, we'll be just right back pretty soon. Okay, let's go for problem 19 or number 6. The tangent to the curve y equals to ax squared plus 2x plus b at a 1.2 passes through the point b 2.8. Calculate the values of the unknown constants a and b. Okay. Huh. Okay. So so yeah, this might seem a bit complicated, but you need to know about some facts about this guy. You need to read this a bit carefully. The tangent to the curve of the function at a 1.2. That means that a is a function. No, sorry. A would be the solution of the function. So let's just go ahead and just put the entire numbers in. Y is 2. There we go. Equals to the x is 1. So a plus b plus 2. So a is negative b. Well, that's quick. Yeah, I guess that's quick. Somehow, somehow I figured out a quicker way. But yeah, we won't need to care about that. And so, another thing that another thing that we want to notice is that it passes through the point B 2.8. And so you know what is the tangent? The tangent here is obviously the gradient. When you just derive the function, you'll get the gradient. But then you know how to figure out the gradient between 2 points because this is a linear system. Because A and B, it passes through the line. So that line, well, actually, yeah. It doesn't say that B actually is in the curve, but that, you know that the line actually passes through point A and point B. So you could figure out what the gradient is. A gradient here would equal to the change of y over the change of x, which you could write as x2 minus x1 divided by x2 minus x1. So yeah, y2 minus y1 over x2 minus x1. So yeah, 8 minus 2 divided by 2 minus 1. This would equal to 6. And this is the answer when you just actually derive this value here first. Y prime would equal to 2ax plus 2. And then after that, you know that the y prime here should be 6 because that's the gradient of the curve when x equals to 1. You need to remember that the x here is 1 because it's the tangent at a. So yeah, that at is the critical point. So yeah, it's 6 equals to 2a plus 2. So you'll figure out that a equals to 2, and you'll figure out that b would equal to negative 2 because otherwise it won't make sense. As that's the answer. That's a pretty quick one as well. Okay, very good. So that's the first part of the problem set that I was gave. So now let's actually go to the next part. So we are going to be going back to first page, number 1. And so yeah, if you don't know the book, yeah, I'm so sorry, but yeah, for you guys who wants to know, is that yeah, this one here is the one from page 357. So let's just solve the third problem first. Number 3, or I'm gonna be labeling this as 1. I don't know why, but yeah. But yeah. So yeah, let's just go and just do that. Number 1, the radius r centimeter of a spherical balloon at the time t. Oh, oh, I didn't actually realize that. Well, actually, it's fine. The radius r centimeter of a spherical balloon at time t seconds is given by r equals to 3 plus 1 plus 2 over 1 plus t. What is the initial radius? And find the rate of change of r when t equals to 3. Okay, first things. Oh wait, actually, I forgot. I need to write this. The radius r centimeter of a spherical balloon at time t seconds is given by r equals to 3 plus 2 over 1 plus t. What is the initial radius? Find the rate of change of r w dot r dot t when t equals to 3. Okay, I don't know what WRT literally means, but yeah. But yeah, somehow that, yeah, they keep on writing that the w dot r dot t. So yeah, I would I would actually just discuss what this because I also don't know. But yeah, it's the rate of change of r according to t, I believe. So let's start this. First things, what is the initial radius? So when you are actually talking about initial, you need to think about what is the radius when time is 0, because it haven't even start. So that's why you start from t is equals to 0, because it is the point where it started to start. Get it? Yeah. So yeah, the first part is that you just need to put in when t equals to 0, r would equal to 3 plus 2 over 1 plus 0, that would equal to, the radius is 5, as that's the radius. Very good, right? Simple. But then you want to find the rate of change of r when t is 3. So you want to know at that time 3, what is the rate of change? Because this guy here actually changes every single time. Instead of a constant or a constant change, this guy actually differs every single time. How could you actually see this? Is that this from when you actually just derive this, when you just take the derivative dr over dt, so the radius over time, the change of radius over the change of time, this would equal to 3. That's a constant, so just throw it out, and then you have this 2 over 1 plus t. But yeah, remember that this guy is a power of -1, right? So that's why you want to have this negative power here. Bring to the front, this entire thing would be the power of -2, or that guy squared. And then you want to take the derivative of 1 plus t, which is 1, so you don't need to do anything. Very good. So you figure out what the rate of change here is. but the rate of change is actually, it is actually reducing. So yeah, I know it's just actually just compressing down, and then when t equals to infinity, or when you take infinite amount of days, years, millennia, centuries, the radius would be a tree. Pretty much close to that. But yeah, we are not really talking about this guy. We are actually just figuring out what is the rate of change when t is 3. So just plug the numbers in. When t equals to 3, when you evaluate this, so when you evaluate the r over dt at t equals to 3, there we go. Solving this would equal to negative 2 over 1 plus 3, that's 4, squared, that's 16. So what you'll get is actually negative 1 over 8. There we go. And that's actually the rate of change. And if you want the units, obviously, the change of radius, in this case, the radius is actually in centimeters, and the change of time, which is given by seconds. So yeah, that. So that's the rate of change during that time. And that's the answer. So yeah. I don't really need to talk a lot, I should say. But yeah, I instead talk a lot. But yeah, I know that it's actually tiring. Okay, the new artboard here for the next problem. Number 2, or in this case here, oh, 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 okay, there we go. Number 2 here for me, it's actually the number 5 in the book. The volume v centimeter cube of a cube at time t seconds is given by v equals to 4. Oh wait, no, actually I forgot. I need to do this. The volume v centimeter cubed of a cube at time t seconds is given by v equals to 4 plus 1 thirds. You know what? I'll just put a t there. Cubed. Find the rate at which its volume is increasing at the instant when t equals to 2. Simple question. So the first thing that you'll actually realize is that I know what the side is. Yeah, that's the first thing that you realize, that wait, I know what the size of the cube is. It's actually 4 plus t over 3. But that's not what the question wants us to find out. Instead, we want to find the rate at which the rate of the volume, the dv over dt. So we want to find what that is. Well, we can just solve this pretty quickly actually. dv over dt, the change of volume over the time here. Let's go and figure that out. So when you just take this derivative, you need to remember of the chain rule. So you first actually do the powers, and then just copy paste the inside there, squared because it's 3 minus 1. But then you want to take the derivative of the inside, which you'll get 1 over 3, crosses it to form yourself a 4 plus t over 3 squared. And so now we want to figure out when t equals to 2. So what's the dv over dt at which time equals to 2? Simple. Plug the entire numbers in. You got 2 over 3, so yes, 14 over 3. It's 196 over 9. And what's the units, you might ask? Centimeter cubed, because that's the volume, the change of volume, over the change of time, which in this case is seconds. Just in case if you need the units. But yeah, that's the answer. Pretty quick, right? So next up, let's actually go to the next one. Number 3, which is the sixth problem. A rectangle has sides x centimeter and 2x minus 4 centimeter. Oh wait, I forgot, I need to do this again. Okay, let's do this. A rectangle has sides of length x centimeter and 2x minus 4 centimeter. And the length x centimeter at time t seconds is given by x equals to 2 plus 3t. T is obviously bigger than equal to 0. Show that the area a centimeter squared wait, what? Plus 3d, yep, there we go. X 2 centimeter squared of the rectangle in terms of t is a equals to 12t plus 18t squared. Hence, find the rate of change of the area at the instant when t equals to 2. Okay, a pretty similar problem. Okay, first things first, we want to figure out what the area is. You can actually just convert the entire x centimeter into t first, which is allowed. Or you could actually just find the entire numbers in, you just plug the numbers in, x times 2, x minus 4, just and then you just use like the factor, you just multiply it and then you'll get something and then you just plug in the t. It's totally fine, but yeah, for me I would just actually just plug the number straight in first. So the line here, so let's actually have this p. Oh, sorry. Let's use base here. B, the base here would be the x centimeter, or 2 plus 3t, and then the height is actually this guy here. 4 plus 60 minus 4 would equal to 60. That means that the area would equal to base times height. This would equal to 12t plus 18t squared. So we have proven this. And now we just need to find out the rate of change, the dA over dt, when time is 2. So you first actually just take the derivative, that's 12 plus 36t. So yeah, you can see that, yeah, the rate of change is actually changing over time. And so when you plug in the 2 in, you'll get 72. That's 84. That's the rate of change. Obviously, the units, if you need them, centimeters squared over seconds. Because you can actually just see it from the units that you have. Pretty easy. Let's go to the number 4. And this number 4, or number 10 in my book, I should say is one of the hardest one. Because personally, I haven't actually finished this without using integrals. Just only by using the derivatives. But yes, I still fail until this point, so yeah. Let's hope I can actually just solve this one. What? The unit doesn't make sense at this point. That's why. Like, yeah, at the book as cubed, but yeah, obviously no. Of a circle increases at a constant rate of 2 centimeters squared second -1 if the initial area of A is 1 centimeter squared show that the radius of the circle at time t is given by r equals to square root of 2t plus 1 divided by pi. Okay. Okay, so yeah. This is a problem that I still actually struggle to solve without using integrals. I still don't know how. Let's actually think. I haven't really think a lot. So yeah. Um I mean, like, yeah. I don't think it's integration. Because, like, yeah, we know when it's a constant rate that it's obviously a t. But yeah, we haven't really actually talked about that. Um, can I actually solve this by another way? So yeah, first things first that we know. Oh no, it's like, yeah. Unfortunately, it's not possible. No, wait, no, it's possible. It's possible. A is pi r squared, right? When you figure this out, you could actually just rewrite this entire thing. You could actually write that r equals to the square root of this a over r squared over pi. Why is the case at the top? So yeah, that's what I figured. And so all I need to do is figure out what like, yeah, this thing basically states that, yeah, show that the radius. Obviously my first intuition states that, okay, with this entire knowledge that you know that the pi is there and the r is there, we know that means that the a must be 2t plus 1. You know what? Let's redo that. A equals to 2t plus 1. Because of some fact that you know. Yeah. And then you can just take the derivative. dA over dt is 2, which is proven. And you know when t is 0, a is 1. C, the thing is correct. Proven. I know this method is not great, but I guess it works. I didn't use integrals, I used logic to solve this entire thing. Well, yeah, that's the that's the second part. Let's go to the third part. Uh, okay. The next problem is on the related rate of change of 3, 4, 5. So yeah, let's go to number 1 again. Of number 3, page 261. The radius of a circle increases at a rate of 2 centimeters second, negative 1. Uh, uh, negative 1. There we go. Oh, why is the dot at the top? Find the rate of increase of its area when. Okay, so yeah, this is a two-part question. The radius is 4 centimeters. Okay, so we are asked to find what's the. Oh, sorry, my bad. What is the rate of. What? So, first things first, we want to do this thing. We know that the area equals to pi r squared. But then you know that actually, well, actually, we want to actually to derive the starting according to time. Remember that we derive this according to time. dA over dt, because that's basically what time is. And so you want to be careful, because r here is actually a function of time as well. You can see here that the rate of the radius, that means that the rate of the radius, that means that the radius is a function of time as well. You need to be careful of this. So when you just take the derivative, it's 2 pi r. Multiply that by the derivative of r, which is dr over dt. And you know what the dr over dt here? It is because of this guy here. The rate of a circle increases at the rate of 2 centimeters squared. That means that this guy here should be a constant. The only thing that differs is the r, the radius. The initial radius. No, how far the radius will actually be. So, when you plug in when the thing is at 4 centimeters, this would equal to 816 pi. That's the rate, centimeters squared per second. Which is correct. Yes, it's correct. But then we have part B. The area is 9 pi centimeters squared. Okay. So, we need to think about this now. I did actually manage to solve this using a crazy thing. But yeah, I don't think that that's allowed. because like yeah, it is totally crazy. But you know what? I should just use it because you know that action that a equals to pi r squared, right? You know, actually, I know, I know how to solve this guy the crazy way. Because you know that the a is pi r squared, you can just write that r must be equal to the square root of a over pi. This is this is actually true. And so when you actually know about this, you just plug it inside the formula just to get that 2 squared pi a pi a multiplied that by pi multiply that by the change of r over t, which is 2 again. So that's 4, and then the area, that's 9 pi, that's 9 pi squared, so that's 3 pi inside there, so that's 12 pi. That's the answer. I would say it's correct. Not gonna lie, it's correct. So yeah, let's actually go and jump into problem number 2. Or problem number 4. Okay? Here we go again. Number 2 or 4. The area of a circle increases at a rate of 2 pi centimeters squared second. Look at 1. Calculate the rate of increase of the radius when the radius is 6 centimeters. There we go. So let's actually just do the powers now. Oh, no, you go up. Yeah, there we go. Okay. So you want to try to find the yeah. Do you so yeah. Previously we actually used that r equals to the square root of a over pi. You could actually just take this guy and just take the derivative. I know, it sounds crazy, but yeah, you can. And so you just basically take the square root of the first one there, half of the square root of a pi, multiply that by the change of a over the change of time. And so when you just actually just figure this out, you just plug the numbers in. So you put this guy in there, but no, this guy here is still an area. So that's why you actually convert it back. Which I know it sounds so stupid, but yeah, that's how I that's how I solve it. So that's 1 over, well, you know that a is pi over squared. Is pi r squared. So when you just plug the numbers in, that would be 1 over 2r instead. And this guy here is actually 2 pi. So you can just cross that out because you're the lucky guy. And then when the radius is 6, that means the rate of change is pi over 6. Which I know is totally crazy, but the answer is incorrect. Wait, what? How do you know that it's incorrect? Because I actually evaluated it and I didn't get the answer. Well, actually I get the answer, but yeah, obviously that I actually calculated this wrong, because there should be a pi right over there. So when you just cross these two out, the pi should go away. So instead you have this 1 over 6 centimeters per second. I know, right? I'm I know, right? I'm a bit crazy, as you know. So yeah, that's 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 the answer. Let's go to the next one. Edit artboards. add a new one there. Problem number 3, or you could say number 5. The radius of a circular disk increases at a constant rate of 0.02 centimeters second to the second -1. Find the rate of increase. No, find the rate at which the area is increasing when the radius is 10 centimeters. Okay, so to solve this problem, uh, so yeah, the radius here would actually be related. The area is with the radius. So yeah, this thing is actually asking about the rate of the area. So yeah, first things that you could actually realize that a equals to pi r squared, which we always know because this guy here is circular. And so when you actually just take the derivative over time, which you have already done multiple times, the a over dt here equals to 2 pi r times r dr over dt, which we know here is a constant rate. So we can just plug the number in there. The radius is 10 centimeters. You can plug this guy here. What you'll get is actually 0.4 pi. Units, centimeters squared per second, if you need it. And yeah, that's my answer. So yeah, that's part number 3. Oh wow. This took me a while. But now it's time for the final one, which I need to find out which page that is. Okay, there we go. It is at page 300 and 384. Ah, I know, it's pretty tiring to do it straight away. But yeah, let's actually just do this straight away. Two variables, x and y, vary in such a way that x plus y equals to 2. Another variable, z, is defined by x squared is by z equals to x squared plus y squared find the values of x and y that make z a minimum. Okay, first things first, we know that x plus y equals to 2, and so you can just actually just substitute it in. How? Let's actually just go ahead and just start by saying that y equals to 2 minus x, because that's basically the definition. So plugging in z here would equal to x squared plus, let's actually just evaluate this straight away, x squared minus 4x plus 4. This would equal to 2x squared minus 4x plus 4. This would be z, and so the change of z over x there would equal to 4x minus 4 when you should just take the derivative. And I can see that this guy here is going to be a minimum. So therefore, at what point will this guy be equaling to 0? This is when x equals to 1, y equals to 1. This would be the minimum. So this is the solution. Wow, I solved that pretty quickly. Not really actually just saying, how did I get this guy here? This guy here is basically, I just see this from the 4. I know that the 4x there would literally define that it would be a minimum. Because of its upward curve. Like, yeah, it curves upwards instead of curving downwards. Yeah, that's why. It arches, I believe. Yeah, it arches up and arches down. So yeah, that's basically. No, I don't know how I should say that, but yeah, let's go to problem 2 or 6. A rectangle. Centimeter. If the area of the rectangle is 60 centimeters squared, show that its perimeter sorry, perimeter p centimeter is given by p equals to 2x plus 32 over x. Hence, calculate the value of x, which gives p a stationary value, and show that this value of p is a minimum. Okay. I'm so sorry about that. But yeah, I just moved the mic a bit. The drink is what I need. So, first things first. Let's just actually write this guy straight away. The area must equal to x times y. It's obvious, so that means we know that 16 plus x, y. And what is the perimeter? You know that the perimeter here equals to 2 times the length of x plus 2 times the length of y. This is basically simple geometry. So when you know that actually y equals to 16 over x, you could actually realize that, yeah, 2x plus 32 over x. And so now we want to find what value of x which gives p a stationary value. I would say it's infinity, but no, obviously that's not the correct answer. So yeah, we want to find gives p a stationary value. Well, yeah, let's just try to figure this out first. Find dp over dx. Let's just do that first. You'll get 2 minus 32 over x squared. X is 4 plus or minus, but yeah, in this case it must be 4 because we are actually talking about length. So yeah, when x is 4, that would give you a yeah, actually, yeah, 4 is a stable one. Well, actually, how do you know that the value is stable? Well, yeah, actually, the a station gives p a stationary value. Well, I mean, all of them actually have a stationary value. So yeah, that's basically that. But yeah, I'll say that x is 4 because why not? So, well, actually, it's plus minus. But then you want to figure out if no, because when you because that's 96 over x cubed. This is the this is the second this is the second derivative. There we go. That's how you actually write it. So that's negative 3, bring it to the front, that's negative 6 over x cubed. And we know that when this guy is actually a positive, because this guy here is always positive, that means that this guy here is always going to be a positive, which means that this guy here would be a curve down. So we know that this guy here is a minimum. Proven. And we figured out that x equals to 4 to solve this problem. Good. As yeah, probably most of you don't really understand how could I actually found this thing, but the best thing is to actually practice. But yeah, I just tried my best to try to explain, but yeah, it ended up actually me not actually explaining, instead actually talking about my craziness. So yeah, let's actually go to the next one. Number 3. Oh, sorry, my bad. Is it fine at this point? Good. Number 3. Or in the book here is the actual number 7. If the perimeter of a rectangle is to be 80 meters, calculate the maximum area. Okay, so you want to try to find the maximum area. First things first is that let's just start by knowing that a rectangle always have its base and its height. So 2b plus 2h must equal to 80 in order for this to be fulfilled. Let's actually go and just use the base here to get 40 minus h. And now we want to find the area equals to b times h. So when you just basically do this, you get 40h minus h squared. And so you want to find out where the maximum would be, so you would take the derivative, or you can actually just, well, actually, yeah, sure. So when you actually just take the derivative there to figure out the maximum point, that's 40 minus 2h, and then this guy here would be a negative when you just actually take this guy, and so we know that this guy goes down. This would be meaning the maximum, which means that the h here must equal to 20 to fulfill this into 0. That means that that's 800 minus 400. It would be 400. That's the answer. That's the answer of this problem. Good. I'm just going to be doing this a bit quickly because I'm tired as well. Okay. Next one. 4, 6, 7. Oh wait, I believe this is the final question. Yeah, it's the final question. Thank you. So yeah, this is the final question. From a rectangular piece of metal of width 2 meters and length 6 meters, two squares of side x, m, and two rectangles of sides x, m, and x plus y and are removed as shown in the figure. The metal is then folded about the dotted lines to give a closed box with height xn. Show that the volume of the box Vn cubed is given by V equals to 2x cubed minus 8x squared plus 6x. Find three significant figures the value of x and of y for which V has a maximum value and show that this value of V is indeed a maximum. Okay, so this is a very long one, but let's actually first just sketch. So first we have this big rectangle here, side lengths of 2 and 6. Okay, but then there's like this small portion here of x by x, another one here, x by x. This would be folded, that's where the dotted line is. And then there's this y. Okay. So let's actually put some dots there, some more there. This is x. This would be y. This crazy bit there. This would be x plus y. That's x. That's x plus y. That's x. Yeah, this guy here is also x. So yeah, we are trying to figure out the volume. Okay, Okay. Uh, okay, I'm so sorry about that. Okay, okay. Okay. So it's something like that. Um, okay. Um, okay. First things first is that we can actually just sketch this entire thing into a model that we have. But yes, I don't. Oh wait, actually, I don't really need to sketch because like I know all of the things. So first things first, we know we know what's the base is. So we have base. No, we got base with height. Okay. So yeah, first we have the base. Base here would be the y. We are gonna be using this guy here as the base. And then after that we would have this other guy here. This would be the width. The width would equal to this 2 here subtracted by 2x's. Lastly, we are gonna be figuring out the height of the object, which is x. And so when you put the entire function, nope. Wait, actually, there is also something that needs to be considered as well. Is that what is this y actually? That's a very critical question. What is the y here? It's actually 6 equals to x plus y plus x plus x plus y. That's 3 x's plus 2 y's. So this guy here is basically 3 minus 3 over 2x. Okay, and so now the crazy thing begins. As I need to figure out the volume. Wait, this doesn't make sense. What? What? This doesn't make sense. Yeah, it's a line of 6 meters. 1, 2. Oh, sorry. Sorry, my bad. It's all 2. So yeah, instead this guy should be 3 minus 1. 3 minus x, yeah. And so you do the crazy multiplications of b times w times h. Okay. So let's first actually do the volume here equals to 3 minus x times 2 minus x, that's 6. And then minus 6x, that's minus 8x. And then that's plus 2x squared. Multiply that by x. This would equal to 6x minus 8x squared plus 2x cubed. Okay, we have proven this first point, that the volume is that. And so now we just need to find out what is the x, y, x and the y's. So first things, we can actually just take the dv over dt. This would equal to 6 minus 16x plus 6x squared. We want this value here to equal to 0. And according to my logic, this needs to be solved by using the quadratic formula. Yep, this guy really needs to use the quadratic formula. So yeah, I will actually use a variant that I love. So yeah, but yeah, this thing is actually still the same. So it's negative b, which is negative of negative 8. That's b. B is negative 8, so that's 8. But I will actually take it by dividing it by 2. Plus or minus the square root of b squared. But I would actually take the the b divided by 2, that's 4, so 16, minus 4ac. The a and the c here is 3, but then for me, I will not use the 4 because this is my own variation, minus 9 that is, over 2a, which for me, I would only need to do a, so that's only 3. And this thing is already very simplified for me. For you, and yes, for you guys, I believe you still need to simplify it, but yeah, it wouldn't be that hard, as you have finally figured out what the value is. But then you also need to figure out what is the real value. Because like yeah, you don't want it to be a very big number or very small number. Because you need to also compare it with others. But yes, obviously we know that from the width is 2 minus 2x. So we know that the x must be smaller than 1. We know about this fact. So yeah, this thing has to be a negative sign. 4 minus square root 7 over 3. So, what's the x here? So, how would you actually solve this is to plug in your, is to take out your calculator. It would be from your Apple stuff. Like yeah, you have those complicated calculators. There it is. Put it on landscape mode. Unfortunately, mine has locked screen, so hold on. Where is it? Is it this one? No, that's not it. How would I actually change my lock? And I don't think this thing could actually be on. No, wait. Let me just try to play around. General display. Don't know. Don't know. Don't know. Don't know. Oh, auto rotate. Do you have any of those? Rotate. Oh, rotate screen, yeah. Left. So yeah, let me just do that again. Device, rotate, left. Sit down, right. What? I don't understand. Huh. Nope, it doesn't work. So yeah, unfortunately my calculator couldn't work. I'm so sad. So instead I need to put it into the Google one. Calculator. There we go. We got the crazy stuff. So yeah, it's 4 subtracted by the square root of 7. There. That's close to cages. That's 1.354. And then you divide it all by 3. That would equal to, so let's do this to that many significant figures. 0.451 What is the units here? Meters. So that's the x. And what about the y? The y here is 3 minus x. So 3 subtracted by the answer, it's 2.55. I think that's the amount of significant figures. Yeah, that's 3 significant figures, I believe. Meters, obviously, don't forget about that. Um, where is it? Or 17. Okay, what number is that? I don't know. Good, very good. Where are the points? Okay, there it is. Yep, that's the answer of the entire homework that I was gave. So yeah, this took me around 2 hours to solve. So yeah, it's a fun thing for you guys to actually solve as well. But yeah, I just want to say thank you very much for you guys who have actually watched the stream. So yeah, we'll actually just gonna be seeing you guys in the next live work. So yeah, thank you very much and see you guys